Okay, welcome back. Today we're going to talk about exponential and logarithms. So what I'm going to do is I'm going to create a series of 4 videos dealing with exponential and logarithms. Over the 4 videos, I'm going to talk about different properties, different formats of exponential and logarithms. Then we're going to start solving exponential problems. So the first thing I want you to do is notice under EXP, this is for exponential format, that b to the x, so b is our base, x is the exponent, equals y. Y is our answer. So to put this in logarithm form, what I'm going to do is I'm going to always start off with log of the base, parentheses, I'm going to put the answer, which is y, and I'm going to set it equal to our exponent, which is x. So on my next 4 problems or examples, I want you all to go put it in going from exponential form to logarithm form. But first, all 4 of these have to be true. 5 squared, it equals 25. 2 to the third is 8. 4 to the third is 64. And 10 to the third is 1,000. Those have to be true statements before we put it in logarithm form. So each one of these are going to have a log. And then I'm going to put the base. The first one, base 5. The second one, base 2. The third one, base 4. And finally, number 4, the base is 10. Then I've got parentheses. And notice one thing with my bases, they're kind of below the log. It's like a subscript. Now, what I'm going to do with the y values are all of my equals. So my first one is 25. Then it goes to 8, 64, and finally 1,000. Then we set every one of these equal to our exponent. So our exponent is 2 for the first one, 3 for the rest of them. Now, one thing I'm going to make note is our calculators read for logarithms base 10. So I want you to, throughout this series of 4 videos, I want you to remember log is paired up with 10. So our calculators do not need, it recognizes as 10, so you will see sometimes log of 1,000. Put this in your calculators. And look what you come up with, 3. Because our calculators read log as base 10. So if you don't see any bases that go along with the log, it's assumed that it's a 10. Now, what happens when you go backwards? So I'm going from logarithms back to exponential. So let's take a look at number 5. Look at our 3 right here. That is our base. Our exponent is the 4, and it equals what's in parentheses 81. So 3 to the 4th, if we put this in our calculator, it's 81. Now if you jumbled up the 4 and the 3 and put 4 to the 3rd power, if you put that in your calculator, it would be 64. This has to be a true statement. Take a look at number 6, 2. 2 is my base, 5 is my exponent. If you punch this in your calculator, you come up with 32. Now finally, what they're going to do on number 7 is try to throw you off. But remember, if there's not a base, it's a 10. So this is going to be 10 to the 4th power equals, you punch this in your calculator, and it's 10,000. This 4 right here, when you have a base 10, this 4, let me put a different color real quick. This 4 tells me I've got 4 zeros. Just like in number 4, look at 3. I've got 3 zeros. Now, this is where I want to add some variables in here. Let's take a look at number 8. My base is 5. My exponent's 4, and I'm going to set it equal to y. But in this case, we can actually solve for y by doing 5 to the 4th power, which is 625. Next, number 9, my base is 6. My exponent is the x, and we set it equal to 36. Now, what number does x have to be? 6 to the what power gives me 36? And most of us know that that is 2. 6 squared is 36. Let's take a look at the last one. 6x equals 35. Now, it looks like number 9, but we're one number off. We're at 35. So our brain should tell us that x is close to 2, but we're not at 2 just yet. Now, wait till my next set of videos, and I want to explain how to solve this 6x to the 35, or equals 35. But now we're going to have to go over some properties. There's 3 properties I'm going to introduce. One is this product rule. Product rule, and then I'm going to talk about quotient rule. And then finally, I'm going to talk about power rule. So first, when we think about the product rule, product means to multiply. That's our answer. So take a look at number 1 right here. Really, we're multiplying a times b. Same thing with log 55 times m. We're multiplying. Now, when we use the product rule, we're going to expand. Some of us have heard the term expand, or we're going to break the a and b apart. We're going to do this by the addition. We're going to add. So this one will be log a plus log b. And notice that the a and the b both get the log. Look at number 2. We're going to separate the 55 and m by the addition symbol. So log of 55 plus log of m. So now, what happens when you have log m plus log n plus log p? Well, since they're all separated by plus signs, I know that that's the product rule. So what I'm going to do is I'm going to put log, and then I'm going to combine them. N times p. That's what I'm looking for, number 3. Now, after the product rule, we have this quotient rule. Now, quotient rule is the opposite of multiplying. It's dividing. That's why you have log and then a over b. So when we think of quotient, I want you all to think about divide. And the end result means we're going to subtract. So the number 1, I'm going to say log a. I'm going to separate them or expand them by subtracting log b. Now notice that whatever is the top of the fraction or the numerator comes first and the denominator comes second. Now on number 2 right here, we're going to kind of combine the quotient rule and the product rule. So let's look at this carefully. I'm going to take log 12 and I'm going to separate it by log d. Now I'm going to also subtract log 24. I'm going to put that in parentheses, and then I'm going to separate that by adding log e. Now, another way we can recognize this is I can say log 12 plus log d, and then if I distribute that negative sign, it'd be minus log 24 minus log e. Either way is acceptable. Now, number 3. Number 3, we're going to go backwards. So I'm going to make this up log 5 minus, and then in parentheses, log 10 plus log a. So I see that I've got a minus sign, so I know that that should be a quotient rule. Then I've got the addition sign, which means a product rule. Now, you just need to have log once, and what I'm going to do is 5 goes on top. The subtraction goes on the bottom, so I'm going to say 10 times a. Now, one thing about it is do not reduce 5 over 10, or in the second one, 12 over 24. Leave it just the same because it is a function. Finally, the power rule. So for the power rule, I want you to think of exponents. And to bring the exponent down is going to be key. So let's take a look at the first one right here. You bring x down, and when we do this, this is when the logarithm comes into play. So it'll be x log 3. If I do the second one, do the same way, I'm going to carry down the 4, so 4 log of the base, which is 12, 4 log 12. Now, what about when you have a radical symbol? Or like what we've been probably taught, the square root symbol. Now, this 3 right here, number 3, that is a square root. So I want to make a little mini lesson here, right here on the right of the screen in blue. Now, square means 2, so really number 3 would have like a little 2 right here. But we just don't have to put it, it's an understood 2. Now, what I want you to think about is, let's think about the exponent now. Because normally we're thinking about x squared, x to the 3rd power, 4th, 5th, and so forth. But now, since we have this radical symbol, this right here, whatever your exponent is attached to this radical symbol, we're going to make it a fraction. The first one is 1/2. So the second one, this cubed root, would be 1/3. And now the 7th root would be 1/7. So if I go back to this problem right here, I know that there is a 2 here. So I'm going to say x to the 1/2. And then when I bring the 1/2 and down, this changes into 1/2 x changes to 1/2 log of x. Now number 4, my last one, I've got the 8, which is my base. My exponent now, if I look at the 7, that's a 7th root. So that means it's 1/7. If I bring this down to 1/7, this would be 1/7 log 8. Now this concludes my part 1 video of exponential and logarithm functions and equations. I will look forward to hearing from you in my second video. Thank you very much.